Hey everybody, so today we're going to be kind of reviewing and talking about how to find distance using coordinate points. So again, this is distance between two coordinate points. Alright, so there are three different ways to find distance. I want you to know them all, and that way you can work smarter and not harder. The first way you're going to do it is a super easy one. If they've given you a graph, and if it's horizontal or vertical, literally, you can just count it. So for this one, you can just count up how many you're going. 1, 2, 3, 4, 5, 6, 7, 8. Woohoo! We can count. Same thing for this horizontal one. 1, 2, 3, 4, 5, 7, 8, 9, 10. Woo! We did it. That's a super duper easy one, all right? But for the diagonals, like you see right here, you should never ever count. Instead, you can use the following. You have two different methods. This first method actually comes from the Pythagorean Theorem, which is our second method, but that's okay. You use what works best for you. Typically, the distance formula, you can use this on either a graph or without a graph. So it's with or without a graph. This one for Pythagorean Theorem, you're going to need to do it with a graph. So if you don't have a graph, you would have to plot it and then take it from there. But let's do our first method of the distance form, which is the distance formula, which is d equals the square root of x2 minus x1 plus y2 minus y1. And each of those is squared. You're adding them together and then you're taking the square root. All right. So your first step is to label your x's and y's. All right. Well, let's figure out what those x's and y's are. So 1, 2, 3, 4. This is -7, -4. This is 5, 2. So here are your 2 points that we're even using, and x2 and x1. So x1 and y1 is one coordinate pair. x2, y2 is another coordinate pair. It's a second coordinate pair. So that's what this 1 and this 2 means. This looks gross. So I'm going to put these first, meaning I'm going to put them into x2. And these is x1 and y1. All right, your next stop, and I'm actually going to color code these for you guys. Your next stop right here is to just plug them in. So first things first, always write down your formula. So you've got d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, it's a lot to remember and it's a lot to write down. So let's plug in our values. We get the distance is equal to the square root of our x2, which is -7, minus our x1 of 5. Notice how I'm putting it into more parentheses. Anytime you're substituting, I want you to use parentheses around it, especially because you've got these negatives that we're having to work with in the middle. It just makes our lives easier in the long run. Plus, y2 is a 2 in this case. Oh, I'm sorry, it's a -4. I'm mixing up my colors. Right? Minus my y1, which is 2. And all of that squared. All right, so your next step is going to be to simplify and solve. All right, so we get d equals the square root of -7 minus 5. Well, -7 minus 5 is just -12. Plus -4 minus 2, that's a -6. And all that squared. We're going to continue on. 12 squared or -12 squared is 144. Plus -6 squared, it's going to be 36. So now what we're going to do is we are going to just go with d equals 144 plus 36. And if you need to use a calculator for this, you can. But you should be fine if you're pre-AP. You can add, hopefully. And you get the answer of the square root of 180. You know that's not going to be a perfect square, and that's okay. All right? But what we're going to do now is you can either simplify it like we talked about it earlier this year, or what we're going to do is I'm going to have you round to the nearest tenth this time. All right, so in your calculators, you're going to do the square root of 180. And you get that the distance is approximately, that's why we're using those two curvy lines, as 13.41640, blah, 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 blah. We only care about the tenth. The number after it is a 1, so it does not round up. And this, in fact, would be your answer. This is your approximation right here, because it's not an exact answer. My exact answer is this one, or when I go ahead and split that up. And that's what we talked about at the beginning of the year. All right, now your second method is similar. This is where the distance formula comes from. And we're going to be using the Pythagorean Theorem, which you guys might have done a little ways back. All right, your first step here is going to be to draw a right triangle, because that's what you can use Pythagorean Theorem with for now. So we're going to draw a right triangle. Oops. All right, count the length of the legs. And then you use the theorem to help you find your hypotenuse. That's what this is right here, your distance. It's actually your hypotenuse. And your legs, each of these legs, are what's going to help us find the distance. So let's find the 1, 2, 3, 5, 6. It's the length of that leg. 1, 2, 3, 4, 5, 6. Oh, would you look at that? 12. 6 and 12. I wonder if we'd seen both of those numbers earlier. Anyway, so now you're going to plug it in to a squared plus b squared equals c squared. So I've got a squared of 6 squared plus 12 squared is going to equal my c squared. All right, well, I know my perfect squares, and I know that 6 squared is going to get me 36, plus 12 squared is going to get me 144, and that's going to equal c squared. Well, 36 plus 144 gets us 180. And that's equal to c squared. We're not done. We're looking for c, the distance or the length, of the hypotenuse. So we take the square root of both sides. So c is going to equal the square root of 180. okay? Units. Or if we're approximating, it's going to be approximately 13.4 units. So notice no matter which way you use, you're going to end up getting the same answer when you've got the same equation here. I want you to use the one that works best for you, but I highly, highly recommend you know the distance formula because sometimes you're going to have it without a graph. All right? I do want you to try this one on your own, and you're going to be submitting this back to me, and you're going to be taking a picture of this. All right. We are going to now work without a graph. So you have to find the distance between 2 points to the nearest tenth. That's to one decimal value. Think about it. A tenth has 1 0, so it's one decimal value. All right, we've got -1, 5, and 0, 4. And I'm just going to label it in order. x1, y1, x2, y2. And that's okay. We'll be fine. Promise. All right, so remember, our distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So now what we're going to do is we are going to go ahead and plug in all of these numbers. So D is going to go ahead and equal. And don't forget, we're going to use our parentheses when we're substituting in. So x2, which is 0, minus x1 squared plus our y2 minus our y1 and all of that squared. So next, our step is to simplify. After you substitute everything in, now you just gotta use PEMDAS because there's nothing to solve for. So we're gonna do our parentheses first. 0 minus a -1 is gonna be a +1 squared plus 4 minus 5, well, that's a -1 squared. D is equal to 1 squared, which is 1, plus -1 squared, which is also 1, which means it's going to be equal to the square root of 2. So sometimes I might want your exact answer, at which point you would say D is equal to square root of 2 units. If you don't remember how to simplify radicals, I'm going to tell you, go look at those notes, because we are going to start using them in a chapter or two. All right? Now, this would be your exact answer. But, you know, we don't remember, or if I'm asking you to round to the nearest tenth, like I did at the beginning of this, then you're going to plug in the square root of 2 into your calculator, and your approximate answer is going to be D is approximately 1.4 units. Remember, we are being asked to round to the nearest tenth. Sometimes you're going to have to round to the nearest hundred, and that's totally fine. All right. So, number 2, let's try it. First step, I'm labeling both of my points. Then I'm going to rewrite my formula. All right, next up, we are going to substitute in all of our numbers. Now, it doesn't matter if you pick your first one or your second one. All right, and in fact, let's change that up a little bit. I'm going to change it this time. So you see that no matter which order we do it, you will still get the same answer. All right, so we've got x2, which is a -1, minus our x1, which is 6. Then we've got that all of that squared plus our y2 minus your y1 squared. Next step is to simplify. So we've got d equals the square root. You're going to do PEMDAS. So your first step will be to do your parentheses. -1 minus 6. So if I'm starting at a -1 and I'm going left 6, that means I'm going to be at -7. You're still squaring that, plus -1 minus 2. Well, that gets us -3. All right, I'm going to keep going. I'm going to switch back to purple. 7 or -7 squared is going to be 49. -3 squared is 9. 49 plus 9 gets you the square root of 58. Again, this would be your exact answer, but we were asked to round to the nearest tenth. So in our calculator, what we're going to do is we're going to go ahead and do 58, and we're going to find the square root of it. And that gets us approximately 7.6 units. All right, make sure that you're boxing your final answer. So after all of that work, you can see what you're working with. Right, you don't need a fancy calculator, just a scientific one will work. And most of your phones, actually, if not all of your phones, already have that feature on them, as well as your Chromebooks.